Hello, welcome to another fun-filled mathematic video. Today we're going to be talking about our introduction to mathematical properties. Most of these are review. You had them last year. And then we're going to, on day 2, we'll introduce our new property and start applying them more. But we'll start with what you guys already know. So our learning target is SOL 716, A, B, C, D, and E. A says we're going to use the commutative and associative properties for addition and multiplication. B says we're going to use the distributive property. C is the additive and multiplicative identity properties. And D is the additive and multiplicative inverse properties. And lastly, we have the multiplicative property of 0. This is also called the zero product property. All right, so if you take out your notes on page 6, if you don't have your notes, there's a link where you can download a copy and print it at home. These are very easy notes. It shouldn't take long, so try to follow along. Okay, so our first property that we're going to look at is the easiest. It's commutative property. And if you think about most of your parents commute to work, so the key word is commute. That means that they start their day at home, then they go to work, and at the end of the day, they go from work to home. But the result is still the same. They're still traveling the same distance. They're just doing it in reverse order. So the key idea with the commutative property, that it works with only addition and multiplication, but it's just simply changing the order of the numbers when you're adding or multiplying. So if you think of an easy example would be 1 plus 6 equals 7. But what happens if I reverse those numbers and say 6 plus 1? I still get the answer 7. It doesn't matter what order I add them in. It's just that we're getting the same answer. So we can change the order of the numbers to make our addition and multiplication easier for ourselves. So look at your first example over here on the right. We have 3 plus 2 plus 1. A way that I could rearrange those letters is I could say 2 plus 1 plus 3. I could also say 1 plus 2 plus 3. There's lots of different ways you could rearrange them, but all we're doing is changing the order of how they're written. So why I might do this, if I know 2 plus 1 is 3 and 3 plus 3 is 6, that makes it easier for me to mentally add those really fast. Another example, if you look at number 2, this is with multiplication. So instead of saying 5 times 8 times 7, maybe we say 7 times 8 times 5. Or maybe we say 5 times 7 times 8. However makes sense to you, you're just taking the numbers and moving into a different order. The last one I want to show you, because this is some of them, the tricky kind of ways that they're going to try to mess you up as you're looking and trying to identify these properties. So remember, with commutative, we're changing the order. If you look at commute, CO, change order, that means I'm changing the order that the numbers are added in. However, sometimes they're going to throw something like this where you've got 5 plus A in parentheses plus B. All you are going to be looking for here is we're going to start with adding B, but we're still going to keep 5 plus A in the parentheses. Or you might see B plus A plus 5. So what's still in parentheses is going to stay in parentheses. We have to add that first, but the order that we write them in can change. So you can change the order that's inside the parentheses, but you cannot change the numbers that are inside the parentheses. That's a different property. All right, our second property is our associative property, and this goes with our associates. That's kind of the key root word. Our associates are our friends. So if you look at this example, we have girl number 1, we'll name her Polly, plus girl number 2, and we'll call her Reba. And we have a boy, and we'll call him Scott. We still have Polly first, Reba, and Scott. They're in the same order, but watch, this is what the associative property means. So in the first time that they're in class, Polly and Reba decided they're going to work together in a group, and Scott is working by himself. However, the next class, they have another project that they're working on, and this time Reba and Scott decide they're going to work together. So with the associative property, all I'm changing is who is working together in the groups, your associatives. It's regrouping the numbers, but without changing the order. You need to know that. It's without changing the order. So it changes who my friends are, and we want to include everybody. So sometimes we mix up our groups of who's in our groups, or sometimes people are dating and then they break up. So you know how that works. So it changes who's in my group, or who's my associate, or who's my partner. So if we look at these examples here, we have 3 and 2 are partnered up, and we have 1. So we're going to rewrite our numbers in the same exact order that they were in before, but now instead of 3 and 2 working together, we're going to have 2 and 1 working together. If we look at the next example, we have 5 times 8 times 7. 8 and 7 were partnered up, but now we're going to partner up 8 and 5. The last example, we have 12 plus 8 plus 10. And in this example, 8 and 10 were working together, so now we want 12 and 8 to work together. And the reason why we can do this and why we would want to do this, if you look at 12 plus 8 plus 10, then I'd get 18 here and 12 here. Well, I'm not super great with my addition, and adding 8 and 2 sometimes messes me up. So if I do it this way, I know 12 plus 8 is 20, and then all I have to do is add 10, and that makes 30. So that's one of the reasons why we use the associative property, is to make our addition or our multiplication a little bit easier. So that's the associative property. Our next property is our identity property. And that identity property is when we're talking about our ID cards. Each of us got an ID card when we got our school pictures taken, and that ID card tells us who we are. I am who I am, and that's my identity. My ID shows who I am. Well, simply the ID, our identity property, says that if I add 0 to any number, say I had the letter B and I add 0 to the letter B, I'm going to keep its identity the same. It's not going to change. What about if I took B and I multiplied it by 1? Does the identity of the number change? It does not. Still just B. So with the identity property, you're either adding 0 or multiplying by 1, but your number, the identity, stays the same. So if you want to highlight that, the number or the identity stays the same. So if we look at our examples, we have 3 plus 0. If I have 3 and I don't add anything to it, it's still just 3. That's its ID. 5 times 1, well, when I multiply by 1, I don't change its identity, so it's still just 5. If I had negative 17 and I added 0 to it, what would my ID be? What's the identity of the number? Still negative 17. It hasn't changed. So what you're looking for is ID. You're looking for adding 0, multiplying by 1. Don't get this confused with our next property, which is the inverse property. When you say inverse, I want you to think of going in reverse, which means going backward, or undoing. You know how sometimes you watch those cartoons and when they make a mistake, they rewind it and they undo what they just did. So the inverse property is undoing or canceling a number. So with addition, if you look at our example up here at the top, we have 5. It's a positive 5. We add the negative 5 or undo that positive 5 by adding its inverse, it's negative 5, to get 0. So if you look back at our identity property, in our identity property, we're adding 0. On this one, we're adding the inverse or adding the opposite. You're adding the opposite here. And when you add the opposite, your result or your answer is 0. So there's a big difference between the identity property that keeps the number the same and the inverse, which is undoing the number and canceling it out. When we're solving equations for algebra, we're going to be using the inverse property every single time. Sometimes it's with addition or subtraction, and sometimes it's with multiplication. So if you look up here at our multiplication, if we have a whole number 8, it's understood to be over 1. So to undo it, we wouldn't use this x, we'd use a dot, but we would multiply by its inverse or its flip, its reciprocal, which means we take 8 over 1, flip it upside down, and multiply it by 1 over 8. And that results in the number 1, and we know that anything times 1 is itself. So that's why we use the inverse. We never get to 0 when we're multiplying, but when we end up with a 1, anything that we multiply by the 1 stays the same. So if we look at number 9, we have 3, a positive 3, and what would we add to it to undo that positive 3? We would add a negative 3 because that's its inverse. If we look at multiplication, 5 over 1, we're multiplying by its flip or its inverse, its reciprocal, which is 1 over 5. That would give me 5 over 5, because 5 times 1 is 5, 1 times 5 is 5, and anytime we have 5 over 5, the answer, or the product, is 1. 5 divided by 5 is 1. Looking at number 11, if I have 3 over 4, and I'm multiplying, I'm looking to undo that by multiplying by its flip. Take this fraction, flip it upside down. Now the 3 would be on the bottom, and the 4 would be on the top. So now if I multiply them, I have 3 times 4 and 4 times 3. 3 times 4 is 12. 4 times 3 is 12. Notice the commutative property here. I'm just changing the order, but the answer is still going to be the same. 12 over 12 is 1. So that's what you need to understand with the inverse. With addition, we're adding the opposite. With multiplication, we're multiplying by the reciprocal, or think of it as flipping the fraction upside down. Okay, last one. We have the multiplicative property of 0. It's also known as the zero product property. And I like to think of this as 0 is a bully, and he takes over. When he takes over the problem, he takes over everything. So anything times 0 is going to give you 0. And you guys have done this since you started multiplying, so this isn't something new. It's just a fancy name for it. So 3 times 0 would give you 0. If I have x times 8 times 0, it's still just going to be 0. There's no surprises. So anything multiplied times 0, 0 is that bully. He takes over the problem, and he eats everything and just leaves himself. All right, so let's look at some sample problems. These are what you're going to see when you look at your SOL or when you do some practice problems in class. So if you look at number 1, which property is shown in the following number sentence? So you're going to be looking, you can put a little note on your paper, look for what has changed. So if you look for what has changed in the problem, then you're going to find what the property is. So we look here, we've got 2x, still 2x, that hasn't changed. We have plus 5, but here we had a plus 0. So 5 plus 0, what property says that if I add 0, I still just have the same number? 5 is staying a 5. Its ID stays the same, so I know that that is the additive identity property. And you can shorten it. You don't have to write out property. Okay, if we look at the next one, this is saying the additive inverse. Remember, with inverse, we're looking at opposite. So when we're talking about additive, the opposite of a negative would be a positive. So if I have a negative 4/5, what am I adding to get to 0? If it's a negative, I'm going to take the same number and just add a positive. So my additive inverse is a positive 4/5. Another example, number 3. Identify each number sentence that illustrates the commutative property of multiplication. So you're looking for the commutative, which means changing the order. And you're also, the other way they'll trick you is they'll give you addition instead of multiplication. So look here, we have addition. Let's look at the order of the numbers. 7, 3, 7, or sorry, 2, 3, 7, 10. 2, 3, 7, 10. Did anything change there? No. The orders of the numbers are the exact same. That's actually the associative property because they're changing who's working together in the groups. Let's look at our next sample. We have 3, 4, 6, 3, 6, 4. I see that 4 and 6 have changed order and they're being multiplied, so that is a sample problem. The next one says 5, 8, 0, and here I have 5 and 0. There's no 8 because they're showing 8 times 0 equals 0. That's the multiplicative property of 0. The next one, 2, 8, 7, 1, 2, 7, 8, 1. So if we look here, we have 7 and 8 and 8 and 7. They're switching, so this is another example. For number 4, identify each equation that represents the multiplicative property of 0. Remember, the property of 0 says anything I multiply times 0 is going to give me 0. So if we look at the first one, I'm multiplying. 7 times 0 equals 0, so that is an example. If you look at the second one, negative 3 plus 3, I don't see any multiplication. It equals 0, but it's not multiplication, so that cannot be it. That's actually the additive inverse. This one, 0 plus 5 equals 5. I'm adding again, and this time the identity of the number is staying the same, so that's the additive identity property. Looking at the next one, 7 times 1 equals 7. I don't even see any zeros, so I know that can't be it. The next one is adding again. It's negative 7 plus 7 equals 0, but I'm not multiplying, so I know that can't be the answer. The last one is 0 times 3 equals 0, and yes, I'm multiplying, and it says that anything multiplied by 0 equals 0. Okay. Looking at number 5, which student correctly applied the additive identity property? So we're looking for adding 0, because when we do the additive identity properties, what am I adding to keep the number the same? So we're looking for the additive identity property. So let's look in this first example, we are looking for where we're adding 0. So right here, I've got negative 6 plus 0, but if you look at my answer, they put it down as 0. Identity says my ID stays the same, so I know that this cannot be the correct answer because they made it 0. Negative 6 can't just disappear. If you look at your next example, we're looking for where we're adding 0, which is right here. 4 plus 0, and again, look what they did. They put it down as 0. We cannot do that. So again, that one's not right. 4 plus 0 would equal 4. Looking at the next one, and this one, we have to, the first one they solved using order of operations, so they did the 0 product property, which gave us 0, but then when they actually went here to 9 plus 0, again, they gave a sum of 0. That cannot be right. So let's look at this last example and see if we actually have one in here. We have a negative 9 plus 0. When they combined those, here's negative 9 plus 0. Oh, but then they combined negative, so right here is where they actually added. Oh, and again, they didn't do it. So did any of them do it correctly? The answer is no. None of them did. And that's a tricky one. We should have had at least one, and that's my fault. Okay, looking at number 6, we're going to name the property. So again, we're going to look for what has changed. We have 8, 3, 2 times 1, And here we have 8, 3, and 2. So where we're seeing a difference is right here, where we have 2 times 1 and then it stays 2. What is that property that says 2 times 1 stays the same? Anytime I multiply by 1, that's the multiplicative, and I'll let you shorten it, property, identity property. It says anything that I multiply times 1 stays the same. This one we're going to skip number 7 because that's the one we're going to learn next class. And then I'm going to let you guys do, and we're going to skip this one too. Number 7 we're going to skip. I'm going to let you guys do number 6 on Edmodo. And if you look at number 8, it should say which students, because I will tell you there's more than one student that correctly applied the multiplicative identity property. So I want you guys to do 6 and 8 on your own, answer those in Edmodo, and I will see you guys next class where we're going to do some more fun property practice.